This is lesson 10.4, box and whisker plots from chapter 10. A box and whisker plot uses 5 data points. The first one being the minimum or the least value. Then we use the maximum value or the greatest value in the data, given data. We use the first quartile, which is Q1. We use the median, and as you know, it's also called the Q2. We don't usually refer to it like that. And then the third quartile, which we refer to as Q3. The whole point of this lesson, boys and girls, is first to make a box and whisker plot, then to analyze a box and whisker plot, which is already given, so you're looking at it and saying, what does this mean? And the third thing is to compare two given box and whisker plots and then see how the data is distributed in both of them. Alright, so continuing. So we have those 5 things that we need, and one important thing you need to remember is that this box and whisker plot has to be made along a number line. Without a number line, there is really no point in making a box and whisker plot. And the number line should include units. Let's say speed could be miles per hour, kilometers per hour, or height, which could be in inches, meters, centimeters. So you will have to have, whatever the given height is, you have to label it. Now, this is how a box and whisker plot looks. If you notice, there are a few dots. These are our 5 dots or 5 points: minimum value, maximum value, first quarter, median, and third quarter. This is called the whisker. These 2 lines, think of it as cat whiskers. So these 2 are called whiskers. And of course, this big thing in the middle is the box. At this end, we have the minimum value. This is the maximum value. The first dot here in the box, this line, which we'll figure out how to do it, is the Q1, quartile 1, first quartile. This line here, or this point here, shows the median. And this one here shows the Q3. Now look at the number line here. The number line should include the minimum and maximum values that are in the data. It should go up evenly, just like here. And this is a generic blank box and whisker plot. If it wasn't, then it would have units. Let's say this was speed, then it would have said speed, miles per hour, or kilometers per hour, or however it is. Okay, now let's go ahead and see how to make a box and whisker plot. The first step is to order the data. The second step is to find the median, the first quartile, and the third quartile. Then we are going to make a number line which will include the minimum and maximum values. So this is just how to make a box and whisker plot. So, and then we are going to plot the 5 things we figured out. Then we are going to draw the box using the quartiles, draw a line through the median, draw the whisker from the box to the minimum and maximum values. And remember, the number line should show the units. That's one of the most important ones. Okay, let's go ahead and make a box and whisker plot. Okay, if you look, I already ordered. I did some steps here. I ordered the data. I figured out the median. I figured out the Q1 and Q3. I didn't want to show it again because you know how to do it. Then I made the number line to include the minimum value and the maximum value. So I have the 0 and the 6 in the number line. Now I'm going to write the next important thing, which is units. In this case, it is time, but the actual unit is hours. So time in hours. All right, now let's go ahead and do this. the minimum value is 0. So I'm going to make a dot at 0, dot at 6, Q1 is 1, Q3 is 3, and the median is 2. So I have all my 5 points. I have all my, oops, I'm sorry. I have all the 5 points here. And this is what we do. You go ahead and draw a line through the Q1. So this was Q1, this is the median, this is Q3, this is the minimum value, this is the maximum value. Okay, draw a line through Q1, make a box. That's all you're doing. And then draw a line through the median. Then you'll go ahead and connect from the box, you'll connect to the minimum value, the whisker. From the box, you'll connect to the maximum value, the other whisker. That's it. We are done making a box and whisker plot. Let's move on. Okay, the next important thing is to analyze a given box and whisker plot. Again, we know that this is the whisker, and this whisker or this part has about 1/4 of the data in it. About 1/4 of the data. Of all the given data values, there are about 1/4 within that whisker. Within this box, there's about half data in the box. And then this last whisker accounts for about 1/4 of the data again. So when you have a given data set, then 1/4 of them are within the first whisker, about half of them within the box, and then about 1/4 of them in the other whisker again. Now, one thing you need to know is that the longer this whisker, the more spread out it is. So from the number line, look at the number line. The longer it is spread out on the number line, the more the data is also spread out. Same case with the box. So if you had a box like this on a number line, let me just make it over this. So if you had another box here, and this box though had something like this, then obviously the box underneath it, so this box is more spread out just because of the way the data is spread out. Okay, a long whisker or box indicates that the data are more spread out. That's what it indicates. Okay, let's go ahead and analyze some data, box and whisker plot. Okay, it says the box and whisker plot shows the heights of the roller coasters at an amusement park. It's asking us what fraction of the roller coasters are between 120 and 220 feet tall. Remember, this is about 1/4 data. This box accounts for about half the data, and this whisker again accounts for 1/4 data. So they are asking us between 120, so right here, so from the minimum value to 220, which is Q3. How much is that? So 1/4 plus a half, so that's about 3/4 of the data. Are the data more spread out below the median or above the median? So that means they're asking, is the data spread out here? And remember, that's the median, so or here. Doesn't it look pretty much even? So we should say neither, and just say that the data are evenly spread below and above the median. Okay, now let's go on to the next question. Find and interpret the interquartile range of the data. This is the easy part. This is your Q1, which is 140. This is your Q3, which is 220. And so interquartile range is 220, take away 140, which is 80. And don't forget the units, 80 feet. This is how you interpret it. You will say that the middle half of the data, because remember, it is the interquartile range, so the middle half of the data varies within 80 feet. That's what you should say. Varies within 80 feet. All right. We are going to do one more example. in this case, the box and whisker plot shows the times that the students in gym class spent on an obstacle course. What fractions spent 110 seconds or less? So again, remember, this is 1/4. This whisker, this box is about half. This whisker is about 1/4. This is the same for any box and whisker plots. This is how the data is arranged. So spent 110 seconds or less. So this is the 110 seconds, which is the Q1. So 110 seconds or less is 1/4. Data more spread out below the first quartile. So is it more spread out here or more spread out here? Take a look. Whiskers seem the same length, so we should say neither, as both whiskers seem the same length, and we should say neither, and we can say that the data is evenly spread. All right, now they are asking us for the interquartile range and to interpret it. Q1 is 110, Q3 is 150. So subtract from Q3 the Q1 and we end up with 40. So IQR is 40 what? 40 seconds. How do you interpret it? We say that the middle half of the data, so we can say that the middle half of the data varies within 40 seconds. Let's go to the last piece of this lesson. This talks about the shapes of the box and whisker plots. So this shape of the box and whisker plots shows the distribution of the data. Remember, we did lesson 10.3 where we talked about skewed left, so something like that, and then we said symmetric, and then we said skewed right. So it's the same thing. If you look, this whisker, the left whisker is longer, so this is like your tail, and you know that if the tail is on the left, it is skewed left, and the data is mostly on the right, data on right. And this one, the two whiskers are pretty much the same length, so this is symmetric. And in this case, do you see the connection between what we learned in 10.3 and this? So this is the tail. In this case, this is the tail, or the whisker on the right whisker is long, and so we call it skewed right, and the data is on the left. Okay, now let's go ahead and analyze some box and whisker plots, double box and whisker plots. Okay, let's take a look. You have two box and whisker plots. Look at the first one. The whisker here is longer, the box is also longer, so the data is more spread out in that when compared to the small one on the same number line. On the same number line, the pink one, or this alligators, is less spread out. Okay, identify the shape of each distribution. I'm going to put C for crocodiles. So crocodiles, I'll say that skewed left, and most data is on the right, because look, this is the whisker and it's longer on the left, so it is skewed left. And then the box is longer, so I'm going to say that so interquartile range is also spread out. Okay, now for alligators, I'm going to say that the box is symmetric and data is evenly spread. So this is what I get out of how to read the double box and whisker plots. Okay. They are asking which reptiles' lifespans are more spread out. If you look, you know, which one is more spread out on the number line? The crocodiles. So crocodiles' lifespan are more spread out because the range, crocodiles, the range, which are the whiskers, more spread out. Okay. Let's move on to the last question. In this case, they have given a double box and whisker plot and shows the length of time in minutes it takes students in your gym class and your friend's gym class to run 1 mile. Now, identify the shape and distribution. If you look at your gym class, the whiskers are pretty much even. The median is in the middle of the box, so it's kind of a symmetric. So this is your class, and in this case, the distribution is symmetric. And then you can say that because the data is evenly distributed on both sides. Please write that in. And then in your friend's gym class, you can say, where is it skewed? Is it skewed? Yes, it is. This is longer, so left whisker is longer, so it is skewed left. Most data is on the right. All right. Now they're asking which lengths of time are more spread out. Whose lengths? You start here, but then you end here, whereas these guys start here and end at the same spot. So your class time, or your gym class, is more spread out. And you can say that the box is longer, so IQR is more spread out, or more spread out, you can say that. Okay, go ahead and finish the next 5 problems, and I'll see you next class. Also, there is a lot of information that was given in this lesson. If you want to, just go back and take a look again. I know it's kind of a longer lesson. See you next class.